I'm going to talk first about sort of what this talk is, just to set expectations. It's called Day 2, a survey of modules, module Menagerie. As a survey, I mean this is kind of like a 101 kind of thing, like when you take a survey course in college. This is kind of an overview of a bunch of things without really going into a lot of detail on any of them. And the specific scope of the talk, if I talk about Puppet code is really sort of, it's compositional. You start at a very high level and you define a thing you care about, kind of like a tip of an iceberg. I care about this giant application. I care about this role. I care about this profile. Underneath that kind of singular top-level name, there's a lot of stuff going on, right? Puppet code, we typically break it from the role, which is a single configuration applied to a target system, into profiles, which are still very high-level business logic type classes. Those are composed of component classes underneath. Component classes themselves are often broken apart into individual kind of implementation classes. And at the very bottom, and also mixed and scattered throughout, we have the types, the providers, the actual things or states Puppet can assert about a system. Tying it all together, we have the language, we have functions, we have sort of the syntax that glues everything into a coherent structure. So this talk is really focused on, I'm not really talking about modules you'll find that do a lot of big things. I'm just talking about building blocks. I'm talking about functions, language, types, defined types, giving you, or ideally, talking about tools to actually write the more interesting things, to write the component classes. Out of the box, if we call these building blocks, Puppet comes with package file service, maybe a block and a rectangle. The idea is, how do you get the triangle? How do you get the column? Where do you go next? My name is Reid Vandewiele. I am what they call a technical solutions engineer at Puppet Labs. I've been working with Puppet and Puppet code since about 5 years ago now, so maybe 2010-ish. Unix Linux system administrator at Portland State University prior to joining the company, and joined full-time about 3 years ago. So that's who I am. That's the kind of the scope of this talk. Again, types, functions, providers. And the assumption about the audience is, if you've been working with Puppet for years, you'll probably have seen most of these. There might be one or two that you haven't, but you'll have seen most of these ideas. But if you just started working with Puppet and you've kind of gone through what Puppet does out of the box, this is hopefully going to show you some additional things, some of which you should just take and put in your toolbox, some of which you might remember later, and I'm trying to do this more specific thing. But again, it's kind of a day 2 after we finished getting Puppet out of the way itself. The way I'm going to break this up is I'm going to make sure to do kind of a cursory pass over what kind of things we're actually talking about, so what goes in a module, or what can go in a module, and then break the survey apart into categories. Those category names are foundational, things that I think people should probably just install, even if they don't have any immediate plans to use them, just because. Missing link, which is focused on a specific problem that someday will be solved in core Puppet, but today just isn't there. Precision configuration, so step up from file, and specialty, which is there's some weird things that Puppet can do. Those are kind of the categories. So starting with Puppet itself out of the box. Puppet is a good toolbox. It's a great framework. It comes with nothing else. There's 46 functions. Puppet comes with functions are like basically things you can do to modify your data, to perform tasks, additions to the language. There's 24 plus facts, so things Puppet knows about a system. I say 24 is the low end because that's sort of what you'll get on almost any system. Depending on the specific operating system, this can go much, much higher out of the box. Things Puppet can interrogate a system about. 48 types, and a whole bunch of other things. So definitionally, function. This is the language. In the diagram, the iceberg diagram, this was the dotted line tying everything together. I'm calling it out specifically because this is something that Puppet comes with a few of, but you can find a lot more of these outside in modules, and you might want to kind of increase your arsenal of functions. Types is the actual kind of the core bit that most of the modules I'm going to be talking about will be adding additional types to your tool belt. This is things like package, service, host, the things Puppet actually makes assertions about, the things that work is actually done on at the end of the day. Defined types are interesting. A lot of the modules I'm going to be talking about, they'll either provide a type or a defined type. And I wanted to make sure just to chart the distinction for anybody who needed a refresher. A type is native. It's implemented in Ruby. The interface in the Puppet language looks the same as a defined type, but a defined type is a compositional piece. It's a container. It usually just allows you to build an abstraction on top of those native types that you already had. It doesn't really allow you to do new work on the system. Classes I mostly won't talk about. Again, classes are sort of higher level than the building block part of it, but they are there and they come in modules. So let me focus a little bit more on that types versus defined type just for a second. If you've seen there's a couple of different ways you can end up seeing the Puppet graph. Deepak mentioned this morning that the graph is sort of the atomic core of what makes Puppet Puppet. And this is a picture of what a catalog might be visualized like at the end of the day. You'll notice that there's a bunch of kind of nodes leading to other nodes leading to other nodes. The ones on the leaves that have nothing else coming from them, those are actually native types. Those are things that Puppet will actually do. Everything else is a container, typically. And a container is either a defined type or a class or something else. But in the end, it's all going to be breaking down to those native types. I wanted to toss it out there as kind of the distinction between a type and a defined type, just so people have that in their head before we keep going. There'll be more of these pictures, these graph pictures in the end, because it's one of the interesting things about what does a Puppet type actually do. All right. So again, out of the box, Puppet comes with a few things. Package, file, service is the classic example. About 34 of them. But where this talk is going to is really where do you go next? A couple of things I want to point out as sort of the key things that core comes with. Core comes with file, which in Unix they say everything is a file. Sometimes it is, sometimes it isn't. But Puppet is really good at managing those. Packages also translate across multiple operating systems. Exec is the bailout. Exec is a type that Puppet comes with that everyone should be familiar with, but it's really the indicator that you're stepping outside of Puppet's framework in order to do something interesting. But it is, I want to highlight it specifically because a lot of the defined types you find in the Forge end up being based on exec, as we'll see as we kind of dive into some of those. So each of these kinds of things, we just did kind of the brief review of, facts, functions, defined types, classes. Puppet is extremely modular as a framework, and a module that you download from the Puppet Forge can contain some or any of these, as well as many other things. Most of what you can end up finding Puppet to do, you can extend in a module. Once you install it, suddenly that functionality is just, boom, available to you to use. All right, so that's the groundwork. We've set the scope for sort of what this is talking about. We've done a review of what you're going to find in a module. The actual survey part, the title of the talk, okay, let's take a look at what I think, for whatever reason, based on 5 years of experience and working with kind of customers in pre-sales and things like that. What do I think you should actually be aware of? What do I think you should just be using? A little bit of why. So foundational is the first category. I try to keep this a little bit short because we only have a little bit of time. I talk fast, usually faster than I do in my rehearsals, but still a limited slot. 2 modules. Most of the time you encounter these ones pretty quick out of the gates. I wanted to go ahead and nail these ones home. puppetlabs stdlib and puppetlabs concat are 2 modules. There's a reason it's called stdlib, and concat is just, we'll get into that one. But these are modules that you should probably just add. If you're using R10K and you're figuring out a Puppet file, you should just add these to your Puppet file. If you're just starting on like a basic test VM, you should Puppet module install each of these. Before necessarily, I would say it's safe to install these before you even know why you need them, because this is going to seriously increase the power and the kind of the elegance of the code that you can write by having these 2 modules. The problem statements that these modules solve, stdlib and concat, is the really simple stuff. It's, I want to do some text bunching. I have a string. It has a capital letter in it. I need it to be lowercase for some reason. I want to make sure that, I don't want to write a whole file, but I want to make sure that a particular line in a very simple sense exists. I need to build up a file not by specifying the whole thing all at once in a template, but piece by piece for some reason. Those are kind of they're little problems. Puppet doesn't have a solution out of the box. These modules provide functionality that gives you kind of additional tooling around it. So stdlib first. Stdlib is big, even though it doesn't really look that way when you kind of just look through the types on the Forge and things like that. It comes with 113 additional functions. And again, functions are in the language. They're what help you write kind of the glue to tie things together. It comes with 113 functions out of the box that you don't get with Puppet. Add 6 additional facts, mostly relating to Puppet itself. 2 additional types, one of which is fascinating and does nothing, and the other of which is like, oh, OK, that's pretty cool. There's also some classes in there that I won't talk about today. But there's a bunch of stuff here. So the functions are mostly, if you're writing Puppet code or reading Puppet modules off the Forge, you'll often see things like validate string, validate regex. Puppet 4 makes it so you don't necessarily have to do that in the future, but there's a lot of stuff out there today that uses it. That comes from stdlib. Stdlib adds set operations, the ability to get the union of 2 arrays or the intersection of 2 arrays, things like that. None of that you'll get with Puppet Basic. And it also has what I'll just call exotic functions. For some reason, they managed to worm their way into stdlib, and it's not really clear why anyone would necessarily use them, or there's a very specific special case for doing a weird thing. So just some examples of this. Simple functions, downcase a string, upcase a string. Do some splitting. So splitting's in core, but interestingly, joining is not in core. You can't join the elements of an array together into a string out of core Puppet for whatever reason. The exotic functions I talked about, the ones that don't make immediate sense and are like, why is this here? There's a bunch of things in stdlib that if you have a weird problem to solve and it involves, like I have this resource already in the catalog and I want to validate it or check it or do something like that, there's like 5 or 6 functions in there in stdlib that'll help you out. Ensure resource I toss on there as an example. I can't go over all of these. But ensure resource does something really weird. It says, you know what? I want to make sure that this file, in this case, exists in the catalog. And it should have these parameters. It looks kind of like a resource statement. Why would you use a function for this? And the extra thing that ensure resource does is it says if that's already defined, don't do anything. Well, if it's already defined, and it already has these parameters, ensure present, make sure the content is this, then I'm happy and I won't do anything. And compilation will proceed. Puppet has this idea of duplicate declaration. You can't make an assertion about a resource twice. The reason is it's thinking, well, maybe you'll make a different assertion, and I can't hold 2 things to be true at the same time. Ensure resource will basically check, see if you've already asserted it. If it has, it won't do anything. If it's been asserted, but the parameters are different, it'll cause a duplicate declaration. It's a safe way of saying this resource should exist, but I don't care if it's already been declared. Probably spent more time on that one than it's worth because I recommend you don't use this. But the point is there's a bunch of interesting functions in here that do very strange Puppet things. So if you find yourself looking for a weird solution, definitely dive into the stdlib to figure it out. Get module path is simpler. It tells you the path on disk to the stdlib module, but that's another example. The 2 types, I'm spending a lot of time on stdlib because it is important. The 2 types out there, I mentioned one is interesting, one's kind of eh. File line is the one I would call kind of eh, honestly, but it's the one that makes the most sense and is most obviously why it's useful. File line is really simple. It says, you know what, I don't care about the file, maybe like a root bash rc. I want to make sure that the path line is exported. File line will let you make sure that a single line in a file somewhere exists. That's all there is to it. It's not that powerful, but it doesn't come out of the box, and it can be really useful in certain cases. The interesting one is the one that does nothing. Ignore most of the code here. I was trying to find a way to illustrate visually what kinds of things it can do. But Anchor is a resource that you'll occasionally see. It was originally created to solve a problem that mostly doesn't exist anymore. Anchor allows you to drop a node into the graph in the Puppet catalog without that node actually doing anything or asserting any state. This is mostly useful so you can declare dependencies against it. Like this resource has to come before this node. This resource has to come after that node. But the node itself doesn't do anything. The example code on there, if you're trying to figure out what it does, is mostly just demonstrating if you have like 2 classes that might exist on the same node or might be on different nodes, and if they're on the same node, there's a conditional relationship, Anchor might help you build that, because Anchor can safely be in catalogs of both nodes that have every class and nodes that only have 1 class, and they can all declare relationships against it. The other weird thing it can do is it can actually pass notifications through. So if a resource notifies an Anchor, the Anchor will automatically notify anything that subscribes to it. So there's interesting things you can do. I don't expect any of this to really stick. It's a survey, and I don't think I'm explaining it as well as I could. But the point is, it's weird. It does nothing. But if you need a resource that does nothing, stdlib gives you Anchor. The other module I'd call foundational is concat. This one, as time goes on and better modules come out, concat gets less and less critical. But back in the day, concat was the only way of building a file besides the file resource. And it was the only way of building a file piecemeal or piece by piece. What it does is basically, it's a very simple pattern, but it's a standard, everybody uses the puppetlabs concat module, a uniform way of achieving it. The idea is I want to first specify somewhere that the file exists, but I don't know what the content is yet. Later, in other defined types and other classes, I might add things to the file. I might say, well, this file should first have a header that is like really important. It should be at the top of the file. And later, I'm going to add a bunch of who knows how much content. And maybe someday I'll add a tail to it. But I can specify in multiple resources different pieces of the content. And the end result will be built into a final file. I started by showing a picture of the graph because I wanted to introduce that picture. And I'm going to show another picture on here again. Concat is a really interesting resource because it is a defined type and does a lot more than you would imagine just looking at that code. This is sort of the graph that gets produced based on those three or 4 resources that we showed earlier. And the reason for that is concat does a powerful thing, but it does it using no additional native resources. It uses only the basic building blocks Puppet gives you, which is file, which is exec, maybe a couple of other things on here. No, it looks like just files and execs. But concat, because of how it works, has to set up a utility class. We see class concat set up on the top there, where it basically prepares a bunch of resources in intermediary state for use. The opt file resource takes a lot of actual work to kind of prep the file on disk, to get ready to run a command to build the final content. And then each fragment is just a file resource. But you wouldn't necessarily imagine that much work was done just by kind of the simple concat code. But defined types can often kind of balloon out into these interesting patterns with a lot of intermediary state. In contrast to that, concat 2.0 is actually under development right now. And it does this interesting thing where it converts concat from a defined type into a native type, which takes the catalog to this, where concat no longer needs to make use of all that intermediary state that it drops on disk. It simplifies down to just actual Puppet providers that know how to do the thing without any sort of piecemeal composition. So a lot of times when you're looking at 2 types on the 4, just something to be aware of is it a native type? Is it a defined type? If it's a defined type, what does it actually break down into? Something kind of curious to keep an eye out for. So that's what I'd call foundational. Again, things that people should just have, should just be aware of. Arguably, some of this should belong in core, but at least in standard lib, if everybody installs standard lib, then it doesn't need to be in core. Missing link. So I wanted to spend some time on something that really should be in core, but isn't. Will be someday, and someday maybe soon. I tossed some ticket references up there. But that is, Puppet is fundamentally just does not have a native ability to retrieve a file from a server if that server is not the Puppet master. It just doesn't. You have to figure out your own way of doing it. And so over time, over the last I think it's literally at least 3 years that I've been aware of it, there have been a series of sort of iterating modules that each try and do this and do it one better than the last one. So we're going to go over those real quick. And the reason is you'll find all of these out there. You'll have to choose one of them to write your own code. Let's kind of just review them real quick. It's a bunch of statements that all say the same thing on this slide. It says I need to download a file, and it's coming from not the Puppet master. How do I do that? There's actually kind of 2 variants of this problem. When I first started at Puppet Labs, I was working alongside nanliu for a little while before he moved to VMware and Bodico. And staging was emerging as the de facto way of getting a file onto a system. Staging is a gigantic mass of Puppet code that eventually boils down into one exec resource. But what it does is it looks like this. And it says, you know what, file can't give me a remote HTTPS source, so staging is going to give me that utility. With staging file, I can say, here's a file I want. Here is a source where it's coming from, usually a web server, and here's where to put it. Staging file is not really the core use case of staging, and it explains nothing about why it's called staging. The reason staging is called staging is because it's actually designed for deploying archives, for deploying zip files, tar-gzs, that should be retrieved, staged somewhere, and then extracted their contents to the final destination. And that's what staging deploy is about. Staging deploy will basically do the same thing staging file does, but then also extract the file. And in this case, you don't have to tell it where to stage the thing in the interim. This is what it looks like on the graph. I mentioned that there's a lot of Puppet code in staging, but unlike concat, it breaks down into a very small number of actual resources. Staging : file has, I don't know how many lines of Puppet code in it, but it's all just about deciding, should I use wget or should I use curl? Maybe I should use PowerShell. And if you passed a bunch of proxy parameters, what flags do those get translated into in the command I choose to run? In the end, it just creates one exec resource, which is going to download the file if it doesn't have it. That's all it does. Extract is the companion to that, which is the appropriate tar or unzip or PowerShell command to extract the archive once it gets there. So wget and pget, MeisterDev specifically in Siberius, I wanted to toss on there as staging did not emerge as a standard. There is no standard, as near as I can tell. Staging is the closest thing to it. But you also have a bunch of kind of modules out there that do just the simple part. wget and pget are 2 that are both approved, which is kind of cool. But wget mostly only works on POSIX systems that have wget, and or Windows systems if you happen to install wget, which is honestly kind of weird for Windows. And Siberius pget only works on Windows. These guys just do the staging file version of it. They just retrieve the file. They don't extract it. They call it good to go. I put them out there because there's a million of this kind out there. And hopefully these two are pretty good, but I know that there's like download files another version. And if you search for wget, you get like 30 results on the Forge. So just wanted to point out there's a bunch of things out there. Two that I really like, so I wanted to highlight as sort of some newer ones that I think are a little bit better. nanliu archive is the natural successor to staging. It's a native type implementation of what staging does, and actually uses Ruby to perform the download rather than a system utility, so it hopefully will be actually work on any system. It does require a gem, which is a caveat, but otherwise it's better than staging in my opinion. LWF remote file is a native Ruby implementation of wget or pget. It doesn't do any extraction, but it does retrieve a file. It does a couple of cool things. Just there's a lot of things out here, and hopefully someday there'll be a solution in core. That's the code for archive and remote file. The other cool thing about archive is this is mostly about application like deployment, right? You have a tarball from an archive server somewhere and you just need to extract it. Usually you don't need the tarball to stick around. After you've extracted it, you're kind of done. The tarball was an intermediary state piece that can kind of go away. Archive does give you the option of cleaning that up afterwards. So after it's downloaded the tar.gz and extracted it, it can delete the tar.gz and still be happy with the final state. So that's kind of the flag in archives cap, the thing to be aware of about it that none of these others really do. So that's a summary. nanliu staging is old and extremely common. You will find it in a lot of existing Forge modules. Archive is the natural successor to staging. If I had to pick one of the single files, I'd pick remote file, mostly because it's a native implementation and it's Ruby as opposed to using PowerShell or using a system command. But there's a couple of Puppet tickets out there that should actually address this in core relatively soon, where the Puppet file resource will accept someday, at the end of the happy story, HTTPS or HTTP URLs. So that's kind of the missing link thing to point out. Next in the survey is precision configuration. And this is, it's like there's a long list of things that you should you encounter and you should be aware of. And it's really kind of specific to like a configuration file format or making setting changes to a specific resource. I chose to highlight 3 file examples and a couple of other examples that are not files, and then mention a generic component that is a little bit developer-y. I wanted to show how it works so you know what it does and sort of what investment you have to put into it to get any value out of it. But it's worth mentioning in terms of making a very precise change to a single setting somewhere on a system. General statement is, I don't know what the file should look like. Maybe I didn't even create it. WebSphere is a good example. A giant XML file was dropped by WebSphere. And I don't care about most of it, but there's a single setting inside that XML that I need to change. How do I do that with Puppet? So again, the first 3 modules I'm going to point out. puppetlabs has 2 of these. INI file is sort of the old and really solid, well, it has some bugs, but the old and mostly solid example of this kind of pattern. Hocon is a newer one. Hocon is so far not, I want to point it out because it's the kind of file. It's mostly useful for Puppet configuration files right now because I'm not sure what else uses Hocon. But it's kind of like JSON, I guess. And YAML file is one that I tossed out there. It's not as high quality, but if you have a YAML configuration file and want to do this kind of thing, it's an available piece. These look like this. You specify just a resource title as usual. You really need to tell it what file you want to operate on. You need to tell it what setting, in the case of INI file, what section, and what setting you want to set, and the value it should have. It's that simple. It's like this is not complicated to do. It's just Puppet you should be aware of this kind of capability. The end result of doing these configurations, each of these is going to set a particular setting. We have foo.baz in the Hocon. We have foo/baz in the YAML. We have foo in the INI. They're all setting it to ensured. This is kind of the end result. If no file exists, each of these will create the file and set the setting. The cool thing about them is if you had a larger file to begin with additional settings inside of it, it would not eliminate those settings. Those settings would still be there when Puppet was done. If the specific key that you wanted to set, say, foo equals ensured, if that happened to be foo equals other, it would change foo when Puppet ran. But it's non-destructive. It's not going to break everything like the file resource would if you had to templatize the whole thing. So it's a little bit more precise configuration. Each of those is a native type. There's no exec. There's no additional sort of functionality under the hood. So if you want to implement your own for a specific configuration file you have, each of those is kind of good examples of how you might go about building that if you want to become kind of sort of a Puppet type or provider developer. 2 other examples on the precision config is not everything's a file, contrary to Unix philosophy. So puppetlabs registry is a core Windows system provider you should just be aware of for setting Windows registry settings. Java KS is an example of dealing with a really hard configuration file that most people, unless you really love Keytool, which I've not actually met anyone who does, dealing with Java key stores can sometimes be difficult. So these modules basically give you types for, again, ensuring the specific configuration of those resource types. Registry just says key and value, what you'd expect, just like a setting. Key store is usually, it's interesting, it operates off of PEM files. It assumes that although you don't like Java key stores, you do like PEM files. And that somehow you put a PEM file on the disk. And it says, you know what, I want the contents of this PEM file to exist in this key store. And you can do that as a trust store. You can set it to trust the certificates. But basically, it's just a resource for manipulating key stores instead of Keytool. Augeas is, if you look at the Puppet type resource, like if you go to Puppet type reference on the docs page, it's automatically generated. Augeas is the very first resource that's referenced. And it's possibly the most confusing. Because Augeas is not a thing. Augeas is a method or a methodology of doing a thing. I have two things on here. The Augeas type itself, which I'll do first, and then a recommendation for how Augeas would ideally be used, which is not usually to natively just run the Augeas type. An Augeas resource looks like this. Augeas, like Puppet, sort of has the concept of a provider. They call it a lens. And the idea is Augeas is going to provide a means of thinking of every file of any kind on the Unix, or yeah, I guess for today it's only Unix file system, as a tree, as a structured tree. And it's going to be able to reference that file using some sort of path context string. So in this case, the context here says /files opt myfile.xml. You'll note that opt myfile.xml is a file path, /files is something else, and the thing that comes after /breakfast menu is sort of an element inside the XML file. But Augeas provides a means of referencing that as a path. It then allows you to perform certain operations on relative paths inside that. So in this case, the end result of this Puppet resource is that Puppet will idempotently ensure that the price element inside the food element that contains waffles in the breakfast menu is always $6.95. It's kind of like an XML, like XPath a little bit. But the idea is, again, I had no idea how this XML file was generated. I have no idea where in the file this food element is, but I can set the price using Augeas. That's the only thing I care about. The problem with Augeas is that even for this demonstration, I don't use Augeas daily. And it took me probably an hour or two to figure out exactly what the syntax was just to make that one change. So unless you want to become an Augeas expert, this can be relatively difficult. There's a lot of lenses out there. It'll do interesting things like manage SSHD configuration files. It'll manage like the yum repositories. It'll do a lot of things. It's very powerful, but it's not as abstract as a lot of the Puppet types that I like to use on a daily basis are. Luckily, for a lot of the default Augeas lenses or providers, Hercules team has done a great thing. Hercules team is on the Forge and has actually provided Puppet native type wrappers for a lot of this. So if I want to manage SSHD configuration, which is a lens Augeas has, there's a Hercules team, Augeas providers, I think it's SSH out there. They'll give me two types. It'll give me SSHD config and also SSHD config subsystem. I think there might be more out there. I can't remember. But the idea is I can say, I want permit root login to be yes. I don't have to deal with the path, the Augeas. I don't have to deal with finding a line in a file or a regex to find it. Augeas just knows how to do it, and Hercules team has provided a native type that knows how to tell Augeas to do it for me. Augeas is really useful in this context and also in the context of as an engine inside a defined type if you want to invest the time and effort in figuring out those set context changes at one point. But it's, especially for people just getting into Puppet, I want to stress, this is not something you have to do to use Augeas. Augeas is powerful. Augeas can be scary, but there's ways of using Augeas effectively today. So that was kind of the precision configuration category. The last thing I was going to do in this survey was talk about something I call specialty. For this one, it was kind of hard to pick. It's like, what is really a specialty? Because there's a lot of weird things out there. I chose a very small number. The first one is people should know about VCS repo. It's kind of specific. It's not super generic, but it does one thing, and it does one thing very, very well. Well, good enough. So let's move into that. So the problem statement I chose for this one is I want to work with a code repository. I want to deploy it to a directory. I want to do weird things with Puppet. In this case, I chose no-op. Let's move into this. VCS repo is, it's been out there for quite a while. If you look at that download number, it's obviously very popular. All it really does is it allows you to say, you know what, I want to have a git checkout of a particular hash or a particular tag in this directory, or I want to have a subversion checkout of trunk here. There's a few providers. I think puppetlabs officially supports 2 of them, Git and Subversion, but it also has like Mercurial, and I wonder if we have a Perforce in there at this point, but there's a few others in the module if you have different kind of VCS systems you want to check out. This is not complicated. It's like, I'm like, how should I talk about this one? There's not much to it, but the cool thing again is as a survey, you should just know this exists. And if you have that problem, you should know this is there to solve it. This is a resource you should be able to have in your tool set. There's a large number of modules, I guess a small number of modules on the Forge that do weird Puppet-specific things. And I chose 2 of them to highlight, one which is useful and one which is maybe just weird. TR-link and no-op is a module that provides a single function. And if you look at the code, it's like 7 lines or 8 lines of Ruby code. It's not very complicated, but what it does is very powerful. If you have the need to sort of, in a sweeping gesture, say, this entire catalog should be no-op under certain conditions, but not all the time, or this class should be no-op, but I don't want to write no-op in every single resource because everything else should be enforced. No-op gives you the ability to do that to a certain degree. What no-op does is, if you just run the no-op function in your site.pp, this has the effect of setting the metaparameter no-op on every resource in your entire catalog, the default value for that, to true. Effectively, unless the resource explicitly overrides no-op and says, I should no-op be no-op false, everything in your catalog will be no-op if you set this function. In this example, I've wrapped it in a conditional. Like if I were to pass a global parameter, either from Hira or from like an ENC, I would have the ability to, from the master, sort of toggle whether or not the entire catalog should be triggered no-op. This also works on smaller scopes, so like inside a class. I think this is Tom Lincoln, one of our professional services engineers, created this. And it's basically for a couple of specific customer use cases where they wanted to be able to like pick out a single node and say, you know what, this node has Puppet running, but for whatever reason, I've chosen that it should not enforce, even if its no-op equals true is set in the puppet.conf on the agent, because I want to control this centrally from the master. So there's a couple of modules out there that do things like this, and I wanted to highlight no-op as one of them. The other modules, just to show really weird things that Puppet can do. This one I'm actually not sure if anyone should use. But I wanted to point it out because this was created as an attempt to solve a really thorny Puppet problem, which is, imagine you have an enterprise application service, and that service really doesn't like having its configuration files modified out from under it while it's running. In Puppet, you need to do something like say, typically you say, this file needs to be edited, have this content, and it's going to notify the service to restart. But if the service restarts and when it shuts down, it writes its old config back to the file, you have a problem. Okay? There hasn't really been a really canonical way in Puppet to do this. And like the application orchestrator problem that was talked about yesterday, I expect that this will be solved in core at some point in the future, but in the interim, there's not a lot of good ways to work around that. Transition is a module that basically walks the catalog to try and get ahead of that issue. What it typically does is if you tell transition a resource, or I guess, let me do this. You have your regular file service pattern there. The file should be modified, have this content, the service should be running, and the file is going to notify the service. What transition does is it actually happens before the file. It says prior to file. Prior to is a transition-specific parameter. What that does is it tells when Puppet evaluates the transition resource, this is at some point in the catalog, you have a dependency tree, it knows what happens afterwards, it knows what's already happened before. Transition is actually going to look ahead in the catalog and say, well, I've been told to check out, be prior to file. So I'm going to walk the catalog ahead of myself and look at file and figure out if file is in sync. That is Puppet going to change this file when it hits it? If the answer is yes, transition is actually going to run against that resource specified and assert a temporary state. It's going to say, I'm going to run the equivalent of Puppet resource service my app ensure stopped. But only if that file is going to change when Puppet reaches it. So if the configuration file is going to change, transition will stop the service, the file will change, the service, when it hits that service resource at the bottom, will be restarted. It has the effect of shutting down the service before the file gets modified and starting it afterwards. When Puppet runs next, because the file is not going to be changed, transition does nothing. This is weird, but I wanted to point out that you can do weird things with Puppet. And if you have edge cases, the other way to solve that is really an exec resource, which I'm not sure is any better. So I wanted to point that out as if you're exploring, like if you have a problem that you can't figure out, I'm not actually saying use this one, but be aware that you can do all kinds of crazy things trying to work around it. And that's what I was going to stop with on specialty. So this is not every module on the Forge. And this is very specifically scoped to what do I think people should sort of have in their toolbox or be aware of after the basic set of modules. And I'm sure that there are more that we could have come up with. And I'm sure that people out here probably have more they might want to mention even during questions. But just a kind of a comment on finding some of these. I selected these ones specifically, mostly based on if there was a specific purpose that I thought needed to be solved that Puppet Core didn't do a good job of solving on day one. And or the interface for the module. In Puppet, they say, what's in a name? Well, in Puppet, pretty much everything is in a name. Puppet is an interface, it's an abstraction. And if it doesn't make sense when you read the name, if the parameter name doesn't make sense, that's additional cognitive burden to understand what's going on. So naming is extremely important to me, the interface, in deciding what actually makes a good module. And the other thing to mention specifically is the community. A lot of these modules, including nanliu archive, for example, are actually managed actively by either community members that are highly active, or there's actually a Puppet community GitHub organization that kind of curates a lot of these and helps keep them on track. And so finding modules that are actively developed and watched by one or more people who are using them especially is a really good indicator of sort of a module that you can get a lot of mileage out of. Again, this was about building blocks. Main idea, if you walk out of here with something, is maybe, hopefully, if you've just started with Puppet, hopefully at least one of those caught your eye as something that's like, okay, I could find a use for that. Or that's a pattern I like. Maybe I can find something that's more specific to my use case. But Puppet is more than just what comes out of the box. It's more than the classes that you'll find in the application modules on the Forge. It's also the extensions that you can make to the framework itself and the primitives you can use to build your own tooling. So if you walk away with one thing, it's that try and find, if you have a problem that you feel is poorly described with Puppet, especially with files or packages, check out the Forge, talk to people here at PuppetConf. There may well be a better primitive for you. Find the tool that actually fits the job. And that's it for the talk. We have a couple of minutes for questions still. Mike?
Thank you. For the staging module, or any of the other ones, we ran into a case where we had to download like a gigabyte bundle. This is Oracle software. Yep. So we don't want it to persist around, but we don't want to be downloading it all the time either. Is there a way to, I've looked at a number of those and I didn't see any sort of like accept, or instead of the creates, something that would indicate we're beyond this stage, don't download it again. You have any recommendations?
That's interesting, and I think it might help if I got a little bit more context about exactly sort of what the use case was, if this was like for setting up a server one time as opposed to this regular operational state.
So like for Oracle software, you're downloading this installer, this bundle,
right.
And then you're going to run it. And for this one particular product, it's like a gig 0.3.
Right.
I want to download it, I want to install the stuff, and then I want to get rid of that binary installer on the hardware because I don't want to just consume.
Right.
Do you upgrade it regularly and do the same gigabyte download with different firewall?
No. I'm just saying, but as we would do our Puppet runs, there isn't like any way that we found using staging to say don't run again unless you leave it there using that creates.
Right. Yeah. So Archive can do, for some small subset of cases, Archive can help with that because it does delete the file after it extracts, but it's not like an Oracle installation where it needs to run a command, for example. I would say maybe check out Archive because it might do what you want, but the only other solution I've ever found was the transition module because it can do something like, it can actually transition a file resource or a remote file resource and say, if this Oracle is not installed, then you should set this file to ensure present as opposed to ensure absent or crazy things like that. But I've not found a good way to do it. And it's one of the, when they were first looking at the application orchestrator, it opens the door to new problems like that, these kind of temporary states. And I know that Puppet Labs wants to have a better solution in core, but for today, I just have to say archive might provide a temporary. You can do an if statement based. Oh, I guess the other pattern to mention is oftentimes this is done with logic in the manifest and facts. So you can say if Oracle's uninstalled.
I know, but you're not really.
Yeah, you're not really.
You're not testing the state at that point. You're just kind of going off the facts.
Yeah, so the comment is you're not testing the state at that point. You're going off the facts. And outside of transition, I don't have anything. It's one of those things where. Spencer, do you have a?
I'll also say that so a lot of people do that with archive, and there's a pretty hilarious bug where it will load the whole thing into RAM before it writes it to disk. So people are like out of memorying their server because they have 4 gigabytes of RAM in Puppet from this file that they're downloading. So just watch out for that and don't be super surprised.
Yeah, and that's archive specifically. Depending on which one you use, some have that problem, some don't.
Yeah, and in archive at this point is also like a Hydra with multiple backends, and it's going to be so good when Felix finally solves this in core. I'll also say this is in flight. What the Puppet community is doing when modules move to Puppet community, what we do is we re-release it under the Puppet Forge namespace, subject to change. So nanliu archive might not be the place to get it in the next few weeks.
Yeah, I actually talked to Nan at this conference. Currently, it's nanliu archive, although the code is transitioned to Puppet community, but it hasn't been released on the Forge yet.
Who? And then Nan came and talked to me.
Just a quick question. Since you've touched on some non-core types, are there any core types that you feel are underused that maybe you'd want to point out to say, hey, nobody touches this, but take a look at it?
So that's a really interesting question. Are there any core types that are unused? So the answer, I want to look at the list because I think there might actually be something that I'd want to talk about if I did. One that springs to mind that I think is interesting, but I don't think it's underused because there's not a lot of use cases for it, is there's a core type called tidy, which does an interesting thing. It basically, you give it a directory and a pattern of files that you want Puppet to clean up occasionally. And if Puppet runs and it finds any files in that directory that match that pattern, it'll remove them or sweep them or do something like that. So there's some weird things in there that don't get a lot of use, not necessarily because they should, but it's like a really specific thing to do. And sometimes that's better belongs in a cron job. But there are definitely things in there to look at. Without looking at a list, though, I wouldn't have anything else to bring forefront, augeas being the exception, which I did talk about at some level. Yeah, that's not to say there isn't anything there, especially if you're on a platform like Solaris. There's a bunch of there's ZFS, cpool. There's some platform-specific stuff in there. There's some OS X stuff in there that you'd never use unless you're running Puppet on a Mac. Definitely don't rule it out. The first thing I'd start by doing is filtering out all the ones beginning with nagios. Those shouldn't be in core.
Yeah, so this isn't really a question, but I think it might be worth mentioning that a bunch of the functions in stdlib in Puppet 4, they can be solved by just functionality in core. For example, the joining of arrays that you mentioned in Puppet 4, you can just do a plus operator on 2 arrays and it will join them. So
yeah.
There's stuff that's solved nowadays if you're using the recent version.
Yeah, if you use Puppet 4, there's 7 or 8 validate functions in there too. A lot of stuff that was in stdlib is in Puppet 4 in the language, which is really neat.
Hi. What I found in my experience with the concat module, it's really bad for kind of seeing what will or won't be changed. So if you do an op run, if you're changing a file by concat, you won't know what happened because it doesn't actually create the file resource because they also run in op mode. Do you know, is that something that's going to be addressed in the version 2? Yeah,
so the reason for that is basically because of that intermediary state thing, where the exec resource, I think, specifically is the problem. It's going to look at the file. The exec resource is going to, because when Puppet runs in no-op mode, it's sort of independently evaluating every resource in the catalog. And because concat depends on that intermediary state that it places, if you independently evaluate the exec without actually doing the intermediate work, exec's not going to fire. In concat version 2, You don't have that problem because none of that intermediary state is there. So it's actually able to compare the content is specified in the catalog with the existing on-state file, and the no-op will be successful. That's one of the reasons Concat 2.0 is actually really exciting, is because it solves, not only does it make the graph cleaner, but it solves that problem. So no-op works much better with Concat 2.0.
I think we have time for one more if somebody's got one.
So there are 116, I think you said, functions in stdlib, growing every day. And a lot of those functions are really weird. And so what we've started doing is when someone shows up with something that is pretty bonkers, we tell them to throw it in extlib instead of stdlib, so that extlib can kind of grow as an incubator, and then people can be like, I use this thing. It sucks, but I use it. So I wanted to make everybody aware of that's another place to go look for really wild stuff. Or throw it if you'd like to contribute it.
That's awesome. Is that Puppet extlib?
It's
Puppet
Puppet
Labs?
Community.
Cool.
All right, I think we're out of time. Another round of applause for Reid.
Thanks.